Our solar system is a vast and mysterious place, filled with wonders that continue to captivate our imagination. We are familiar with the planets and their moons, each with its own unique characteristics and mysteries. But there is much more to discover beyond the familiar, in the vast stretches of space that lie beyond the known planets. Far beyond the orbit of Neptune, there lies a realm of icy bodies known as the Oort Cloud, a region that remains largely unexplored. It is a sphere of icy objects that encases our solar system, forming a distant boundary that marks the edge of our sun's influence. This distant region is so far away that it is difficult to observe directly, making it one of the most mysterious parts of our solar system. The Oort Cloud marks the edge of the sun's gravitational influence, a boundary that defines the outermost reaches of our solar system. It is about 50,000 AU from the sun, an almost incomprehensible distance. That's 50,000 times farther away than the Earth is from the sun. Imagine the vastness of space that lies between. The Oort Cloud is a fascinating and enigmatic region of space, filled with ancient icy bodies that have remained unchanged for billions of years. It is a relic of the early solar system, a time capsule that holds clues about the formation of our sun and planets. Studying these ancient objects can provide valuable insights into the processes that shaped our solar system. The Oort Cloud is also a source of comets, which are icy bodies that occasionally plunge into the inner solar system, bringing with them material from the outer reaches. These comets can provide a wealth of information about the conditions in the early solar system and the materials that were present. Studying the Oort Cloud can teach us a great deal about the history and evolution of our solar system, offering a glimpse into its distant past. It can also help us to understand the formation of other planetary systems around other stars, shedding light on the universal processes that create worlds. The Oort Cloud is a theoretical concept, a vast spherical shell of icy objects that is believed to surround our solar system at a great distance. It is based on observations of comets that have very long orbital periods, often taking thousands or even millions of years to complete a single orbit around the sun. These comets are thought to originate in the Oort Cloud, a region so distant that it remains largely a mystery to astronomers. They are nudged out of their distant orbits by the gravitational influence of passing stars or other celestial bodies, sending them on long journeys toward the inner solar system. The Oort Cloud is thought to be composed of trillions of icy objects, ranging in size from small rocks to large comets, all remnants of the early solar system. These objects are thought to be remnants of the protoplanetary disk, the cloud of gas and dust that surrounded the young sun over 4.6 billion years ago. This disk of gas and dust surrounded the young sun, gradually coalescing into the planets, moons, and other bodies that make up our solar system today. The Oort Cloud is so far away that we cannot observe it directly with current technology, making it one of the most elusive regions of our solar system. However, we can infer its existence and properties by studying the comets that come from it, which provide valuable clues about this distant region. The comets that come from the Oort Cloud are called long-period comets, and they are among the most fascinating objects in our solar system. These comets have orbital periods of more than 200 years, with some taking thousands or even millions of years to complete their journey around the sun. Some long-period comets have orbital periods of thousands or even millions of years, making their appearances rare and spectacular events. Long-period comets are different from short-period comets, which come from the Kuiper Belt, a region much closer to the sun. The Kuiper Belt is a disc-shaped region of icy bodies that lies beyond the orbit of Neptune, and it is the source of many short-period comets. The Oort Cloud is named after the Dutch astronomer Jan Oort, a pioneering figure in the field of astronomy. He first proposed its existence in 1950, a time when our understanding of the solar system was still evolving. Oort was meticulously studying the orbits of long-period comets, those that take more than 200 years to complete an orbit around the sun. He noticed that these comets seemed to come from all directions in the sky. This was unexpected and intriguing. Astronomers had previously thought that comets originated from the plane of the solar system, much like the planets and asteroids. Oort realized that the comets must be coming from a vast, spherical cloud of objects that surrounds the solar system, extending far beyond the known planets. Oort's hypothesis was based on his detailed observations of comet trajectories and their peculiar orbits. he noticed that there were more comets with orbits that took them far out from the sun than there should be if they were simply scattered randomly around the sun. He reasoned that these comets must be coming from a distant reservoir, where they were only weakly bound to the sun's gravity, allowing them to be easily perturbed into the inner solar system. Oort's hypothesis was initially met with some skepticism, as it challenged the prevailing views of the time. However, it has since been supported by further observations and theoretical modeling, solidifying Oort's place in the annals of astronomical history. The Oort Cloud is thought to have formed early in the history of the solar system. About 4.6 billion years ago, the solar system formed from a collapsing cloud of gas and dust. Most of this material collapsed to form the sun. The rest of the material formed a rotating disk around the sun. This disk is called the protoplanetary disk. The planets formed from the material in the protoplanetary disk. The icy objects in the Oort Cloud are thought to be remnants of the planetesimals. These are small bodies that formed in the protoplanetary disk. The planetesimals that formed close to the sun were heated by the sun's radiation. This caused them to lose their volatile materials, such as water ice. However, the planetesimals that formed farther away from the sun were able to retain their volatile materials. These planetesimals are thought to have formed the Oort Cloud. Section 5. Icy Wanderers, Comets and Their Origin. The Oort Cloud is a rich source of comets. Comets are icy bodies that are left over from the formation of the solar system. They are composed of rock, dust, and ice. The ice in comets is mostly water ice. However, it also contains other frozen gases such as carbon dioxide, methane, and ammonia. Comets are often called dirty snowballs. When a comet approaches the sun, it heats up. This causes the ice in the comet to vaporize. This forms a cloud of gas and dust around the comet's nucleus. This cloud is called the coma. The sun's radiation pressure and solar wind blow the coma away from the comet. This forms the comet's tail. The tail of a comet can be millions of kilometers long. Comets are fascinating objects to study. They provide us with clues about the composition of the early solar system. Section 6. Cosmic Dance, Stellar Encounters and Their Effects. The Oort Cloud is not a static structure. It is constantly being perturbed by the gravitational influence of nearby stars and the Milky Way galaxy itself. As stars pass by the solar system, their gravity can nudge Oort Cloud objects out of their orbits. Some of these objects may be ejected from the solar system entirely. Others may be sent plunging toward the sun. These stellar encounters can have a significant impact on the number of comets entering the inner solar system. When a star passes close to the Oort Cloud, it can trigger a comet shower. This is a period of time when the rate of comets entering the inner solar system is significantly increased. Some scientists believe that these comet showers may have played a role in the evolution of life on Earth. Section 7. Oort Clouds Beyond Our Sun. Astronomers believe that Oort clouds are not unique to our solar system. They are likely a common feature of planetary systems. Theoretical models suggest that most, if not all, stars should have Oort clouds of their own. These clouds would form in the same way that our own Oort cloud formed. They would be composed of leftover material from the formation of the star and its planets. While we cannot observe these Oort clouds directly, their presence can be inferred by studying the comets that they produce. As stars pass by each other, their Oort clouds can interact. This can send comets hurtling toward the inner regions of these star systems. By observing these comets, astronomers can learn about the properties of Oort clouds around other stars. Section 8. Unveiling the Secrets of the Oort Cloud. The Oort Cloud presents significant challenges for exploration. Its vast distance makes it difficult to observe from Earth, and even more challenging to reach with spacecraft. Currently, no spacecraft have visited the Oort Cloud. However, there are several concepts for future missions that could shed light on this mysterious region. These missions include using telescopes to search for faint objects in the Oort Cloud, sending spacecraft to fly through the Oort Cloud and analyze any particles they encounter, and developing new technologies for interstellar travel that could one day enable us to send a probe to the Oort Cloud. Section 9. A Realm of Endless Wonder. The Oort Cloud is a testament to the vastness and mystery of our universe. It is a realm of icy bodies that hold clues to the earliest days of our solar system. While it remains largely unexplored, the Oort Cloud continues to captivate our imaginations. It serves as a reminder that there is still much to discover beyond the familiar planets and moons that we know so well. As we continue to explore the cosmos, the Oort Cloud will undoubtedly remain a source of fascination and inspiration for generations to come. It is a place where the boundaries of our solar system blur with the vastness of interstellar space. It is a place where the past and present intertwine. It is a place where the mysteries of the universe continue to unfold.